Sure. So this morning we talked about how to pass functions into other functions and we run it, and then we capture the output. Well, I guess it stands to reason that if functions are just variables that we can pass into other functions, then it also means that functions are variables that we can return from other functions as well. So we're going to spend a little bit of time talking about that, and then we're going to also introduce this idea of closure and give some like I guess some introductions as to kind of when it's really useful, and why it's a pretty powerful concept in JavaScript. Okay, so I have my returns a string function, and it returns a string. And so whenever I invoke the returns a string function, the return value is going to be a string. On line 7 there, it's really important that I basically capture the return value of the returns a string function in a variable, right? If I don't do it, then it returns a string variable. It's going to return a value, but I don't capture it anywhere. It just kind of goes and disappears forever. And so whenever you're doing anything that requires you to use whatever a function gives back to you, always be sure that you're storing it somewhere. Otherwise, otherwise it kind of defeats the purpose of running the function in the first place.
So you're talking about the I am a string.
Yeah, exactly. So right here on line 7, on the right hand side of the equal sign, returns a string when invoked, returns back I am a string, and we need to store that somewhere, because if we don't, then we'll basically lose access to that. Okay, so we can return strings, numbers, booleans from functions, but because functions are just like everything else, we can also return functions from within other functions. So here on line 1 through 3, we have a function called greetMe, and on lines 5 through 7, we have a function called getGreeter. Notice how on line 6, we're returning greetMe, but we're not returning the function as if we're calling it and returning the return value. We are returning the function greetMe as a variable, right? So you know how like earlier this morning, we talked about us being able to pass functions into other functions without invoking it. Like we have the choice to either pass a function as is, right, as in like a plain box, or we can do something, or we can run the function first and then return the return value. And so on line 6 here, we see the word greetMe, but notice how there's no open and close parentheses after it, which means we're not invoking greetMe. We're returning greetMe purely as a variable representing the functions on lines 1 through 3. Okay, so on line 6 we return greetMe function, which means on line 9 there, when we invoke getGreeter on the right hand, or sorry, on the right hand of the equal sign, getGreeter, after we invoke it, essentially returns greetMe. And so the greeter on line 9 there becomes the greetMe function. And so on line 11, when we do type of greeter, and also when we look at greeter, and also when we invoke greeter, we see that type of, it's a function. When we console log out a function, that's how it prints out as function with a name. And then lastly, when we invoke greeter on line 13 there, it's the same as us invoking the greetMe function on line 1. And so therefore, that's why we see the console log out hi. Make sense? No?
No. I mean, it makes sense, but it didn't say
Okay. Yeah. Yeah, I mean, a lot of this just takes time to kind of digest and get familiar with, but like the short of this is also just, once again, right, when we talk about returning values, like at every stage, be very, very clear in your mind about what's being returned, where you're storing it, and whether or not what you're returning is a function or a variable or the return value of the function, right? Like the biggest kind of pitfall here is people see, oh, on line 6 I return greetMe, therefore I must be invoking greetMe, and at no point do we ever invoke greetMe on this page up until line 10. And so just make sure that you're clear in your mind about greetMe is a function. It's not what greetMe returns just yet. What greetMe returns only matters once we actually invoke greetMe, which we do on line 13 there.
But the part that's confusing is you're invoking greeter.
Yep.
So if greeter is equal to getGreeter, but getGreeter is not the invoked function of greetMe, it's just the function greetMe. When you invoke greeter, well, I guess greeter is equal to the function greetMe, so it's like you're invoking greetMe because you've invoked greeter.
Okay, Cool. All right. So here's where we're at right now, right? Let me. Cool. All right. So here on line 9, we are on line 9 is kind of the first time where we run code, and we're invoking getGreeter, right? So when we invoke getGreeter, what does getGreeter return?
The function greet.
Great. So this now becomes what?
Greet me.
Okay. So now when I invoke greeter on line 13 there, what am I really invoking?
The function greet.
Great. Right?
Right. Yeah. Thank you.
Yep. Ah, bad. Okay. Yeah, for this lesson, if you're not comfortable with returns, like practice it, look at it, like do some research on it. Like this is where like being able to actually be able to keep your mind what's being returned at which point is extremely critical. Okay, so similarly, the next example is going to be, hey, well, what if we don't return greet me as a function? What if on line 6 there we actually invoke greet me first, and then we return whatever value that returns? Well, so if we step through this code here, lines 1 through 3 we're defining a variable, nothing's being executed. Lines 5 through 7 we're defining a variable, nothing's being executed. On line 9 we say let greeter equals, and we invoke getGreeter, right? When we go into getGreeter, we go into line 5, and then which takes us to line 6. On line 6, it says return greet me invoked. So now our job is to figure out what greet me invoked returns. And so what does greet me return? Or what does greet me when I invoke it? What does that return?
Hi.
No, it doesn't return hi. Where there is no return statement in the greet me function, right? Right? Return. Like we look for the word return, and if it's not in there, then we know it's undefined, right? So the greet me function console logs out hi, but it doesn't return anything explicitly. Cool. You all were like super confident there that was hi. Like everyone was like really confident. Like it's the first time I heard you all say something like unison, because usually it's like more like people kind of having a guess. But yeah, so on here the greet me function on line 1 through 3, it doesn't return anything. Like we don't tell it to return anything. So by default, it's going to return back undefined. So on line 6, return greet me invoked becomes return undefined, right? And so then the question becomes, well, great. What are we returning undefined to in getGreeter? We return it to whoever called getGreeter. And where did we call getGreeter? We called it on line 9 there, right? So after line 9 runs, greeter is equal to undefined. So when I do type of greeter, I get back undefined. When I console log out greeter, I get back undefined. And then when I invoke greeter, I get back an error saying I cannot invoke something that's not a function. Cool? All right. Okay. In this example, in this next example, there's not anything really new going on. It's just this idea that like in this getGreeter function, when we invoke getGreeter on lines 3 through 5, we actually create a function that's contained within the scope of getGreeter, and then we return. Sorry, we create a function called greetMe in the scope of getGreeter, and then on line 7, we return the variable greetMe, right? So on line 10, when we run getGreeter, well, when we run getGreeter on 10 there, it's going to take us back to line 1, which will take us to lines 3 through 5, in which we create this variable called greetMe. And on line 7, we return greetMe. So then, where do we return greetMe to? We return greetMe to whoever called getGreeter, which once again is on line 10. And so greeter becomes greetMe. And when we invoke greeter, it's the same as us invoking greetMe. Make sense though? Yeah? Okay, good, great. And then this is the last one of these kind of like same idea, just different implementation. This idea that like we can create a variable, and have it contain a function, or we can just create and return the function directly, right? So here between lines 3 through 5, we see we have the return statement, and after we just kind of make the anonymous function on the fly, and that's totally fine, right? In this case, we're also returning a function value. And so once again, on line 8, when getGreeter runs, what we do is we actually return a function, and we don't know what the function is called, but we know we're returning a function that console logs out hi. After line 8 runs, that function becomes, or greeter becomes that function, and on line 9, when we run greeter, it's the same as us running that function, so we still get to console log out hi. That's you. Everyone good? All right. And because these are all functions that come with like the full spectrum of functionalities of functions, if our function takes in a parameter, that's great. It just means when we call the function, we need to pass in parameters too, or pass in arguments. Right. So after line 8 runs, getGreeter returns a function. So greeter becomes that function, but that function expects a name parameter, or rather a name argument. And so when we invoke greeter, we're basically invoking that function, and so we need to pass in, in this case, a name to the greeter function. Yes.
I have a question. Does the return function has access to the variables of the getGreeter scope?
Yeah, we do, and that's kind of where closure comes in. So we'll talk a little about in like 2 more slides. Yep. Notice how here when we invoke greeter, we just pass in a name to it, and if we don't pass in any variables, or if we don't pass in any values into greeter, by default that parameter still exists. The value of it is just undefined. So when I console log out hi name, I get back hi undefined. Okay, cool. So back to closure. To closure now, I guess. So if you remember on, I guess, last Sunday when you worked with Sam on this idea of scope, we talked about how basically scope basically means it's defined by the curly braces, but scope always looks in itself first, and then looks at the next outer scope, and then the next outer scope, and the next outer scope, and so on and so forth, until it reaches a global scope. And if it doesn't find it by then it's finished, right? As in, you can look in your parent scope, but you can't look in your like children's scope or in your sibling scopes, right? So one of the things that is really kind of powerful, the idea there is just like, yeah, when I create a variable inside a scope, it means only the things inside that scope have access to it. Like outsiders can't look into my scope and see what my variables are. On the other hand, here, one of the things, or rather, what closure kind of allows us to do really. Actually, no. Let's finish this review first, and then we'll talk about closure. So here, I have a function called greeter, and it creates a scope there between lines 6 through 12. Notice how I create 2 variables. One is called name, which is a string Marie, and one is called says hi, which says hi name, right? So when I invoke says hi on line 11, I said the says hi has access to the name variable Marie, right? Because they're both in the same scope. So when it looks in its own scope first, it will find that variable name. Cool. So this is how our standard understanding of scope works. However, what's really cool about closure, this is a text here. What's really cool about closure is for that says hi function, even if I take it outside of that function scope, I still have access to the variables inside the original parent scope. And that's because, once again, scope is created not based on where the code is running, but based on where the code was, or rather, closure is not dependent on where the code is running. It depends on where the code was made. And so here, on line 1 here, or sorry, when we go through this function, on line 13, we say let greeter equal, and then we invoke the getGreeter function. If I step into getGreeter, the first thing I do is on line 2, I console log out getGreeter is running. On line 4, I create a variable called name equals Marie. On line 6, I say getGreeter is finishing. And on line 8, I return a function that console logs out hi name, right? In this case, this is an anonymous function, but it's just a function, right? And so then we return that function to whoever called getGreeter, which is on line 13. And so therefore, after line 13 finishes running, greeter is basically the same as the anonymous function between lines 8 through 10. And so when I invoke greeter on line 14, even though I'm invoking greeter outside of the scope of the get greeter function on lines 1 through 11, that function still has access to the variables inside of the getGreeter scope because that's where the function was created. And so therefore, when I run greeter on line 14, I am still able to get access to the name variable in the getGreeter scope on line 4 there. And so that's why on line 14, when I run greeter, I am still able to print out hi Marie. Because when I run that function, the function says, okay, great, you want me to print out hi and the name. Let me look for name. Is there a name in my function scope? And the answer is no, there's not. Is there a name in my parent scope? And my parent in this case is a getGreeter function, and the answer is yes. So I'll use that variable as my parent, or as the value for the name variable. Cool. So yeah, so this is really powerful because now for the first time, if I create a variable in a function or in a particular scope, I almost have a way to kind of export this variable to other places so that other people can use it, right? So if I want to share name with anyone else, all I gotta do is if I say, hey, here's a function that has access to name, whoever has that function can now get access to that name variable, right? Organically speaking, no one else can look inside the getGreeter function still, but I am now able to export my name variable by putting it inside a function that I can then export elsewhere. Hubert?
Where does when you call greeter?
Yep.
Where does it look for name?
Yeah, so when I invoke greeter, I'm basically invoking the function between lines 8 through 10. The first place I will look for the name variable is within its own scope, which is lines 8 through 10. And it'll say, hey, rather not lines 8 through 10, but basically this function here, the first time I invoke greeter, it will try to invoke this and it'll say, oh, hi, I'm expecting a variable called name. It will look in its own scope, which is this highlighted portion, and say, do I have a variable called name? And the answer is no. So then it'll say, great, let me look in my parent scope. Well, its parent scope, because this function was created within the getGreeter function, its parent is the getGreeter function. And
Is that gone though? Because once it runs, then the return value is given to greeter, so it's done, right?
well, functions are reusable, right? Like once I return a function, people can call that function as many times as they want, right? So the idea here is that once I create this once I create this function and I return it, what I'm doing is I'm basically saying, hey, here's this function that is going to permanently have access to the scope in which it was created, right? It's almost like a memory, right? So in this case, this function is always going to have memory of the scope in which it was created. And so even when I use it outside, or when I use it on line 14 here, it's not rerunning all of greeter again. It's just saying, oh, I'm running this function, and this function has access. It has a memory of all the variables it had when it was created, and one of those variables was name.
So yeah, so is it stored anywhere?
The short answer is yes, because when you run an instance of something, like the values are cached in the computer's memory. But it's less about like where it's stored and more like do you have permission to access it, right? Because the whole idea behind scope is not that like, oh, like we don't have room to store this. It's more like when I create this thing, it's permanently in storage, but I don't want people to have access to it, right? And so closure lets you kind of bypass that by saying, hey, this function created a bunch of variables, and by the way, here's a way for you to access those variables still. Okay, cool. So then, and this is now we're kind of belaboring the point here, right? The point behind this is that, hey, once again, these are functions, right? So they should be set up to take arguments in. In this case, we're returning a function that console logs out hi name, but the name also, in this case, we never explicitly create a variable called name, but there's a parameter called name in getGreeter, and so when we do that, when we run this function, when we run this function called greeter on line 9 there, the greeter basically becomes the anonymous function between lines 3 through 5. When we invoke greeter, we're basically invoking that anonymous function. The anonymous function is going to console log out hi name, it'll say, great, where do I find name? Is there a name variable in my own scope? And the answer is no. So then it'll say, is there a name variable in my parent's scope? In this case, their parent is the getGreeter function, and the answer is yes. There is a name variable. It is a parameter of whatever I was invoked in the first place. And so in this case, the name is Rosalind. So when I invoke greeter, I get back hi Rosalind.
If you didn't input Rosalind, you would get back hi on the phone.
Yep.
And then does it look also in the global if you have a yeah? It jumps from
If
there?
eventually it would, yes. But remember how scope works is
Yeah,
as soon as it
so
finds a hit,
it's
it stops.
okay.
Right.
Jumps there, okay.
But yes, you're right in that if we had a variable called on the global scope called name and we didn't have one in the parent function, it would eventually get to that point. And then this is just kind of more like more shenanigans, same idea. It's like what if both functions have arguments or have parameters? Well, in this case, when I do hi name1 meet name2, what I'm really doing here is saying, hi Marie, or hi Marie meet Rosalind, because when I invoke that function, I look for name1 in my own scope. I don't see it, so I go to my parent's scope, which is getGreeter. And I see name1 with the parameter. When I invoke greeter, I also need to pass in. Sorry, this is really hard to explain. Just copy this down here. Okay. So here, when I on line 21, when I run getGreeter, greeter essentially is equal to this function here, except the only difference would be that name1 is no longer name1. What is name1? Right? So basically, after line 21 runs, that's what greeter becomes. It becomes a function still, and it's programmed to say console log out hi. Before we had name1, but remember when we created this function, we already have a name1, right? This name1 value is cached. It's enclosed upon by this function, so we know that this function is going to say hi Marie meet, and whatever we pass it as name2. So we invoke greeter Rosalind, we get back hi Marie meet Rosalind. And then this is the last example. Once again, same idea, right? In that, like here, notice how on line 7 through 8, we're invoking the getGreeter method twice, right? Each time, what getGreeter is doing is it's creating a new instance of getGreeter, is running all the code from scratch, and it's returning a brand new function. Now, these two functions do the same kind of general thing, but these are two distinct functions, right? On line 7, when we invoke getGreeter and we pass in Marie, name1 is stored as Marie, right? And the function that's being returned there that we store introduce Marie to, and to that function, name1 will always be Marie. On line 8, when we do introduce Rosalind to, we still call getGreeter, but then we pass in Rosalind as name1. So when that function returns, when that returns a function, to that function, name1 is always going to be Rosalind. And so therefore, on line 10 through 11, when I say introduce Marie to and I pass in Dorothy and then Albert, it knows to say hi Marie, meet Dorothy, meet Albert. On line 13, it knows to say hi Rosalind, meet Barbara and Isaac. And so this is just to illustrate the point that I can run getGreeter multiple times, and each time I run it, I'm creating a new version of getGreeter and a new version of name1. And a new version of the function that recognizes that new name1. Yes? Good? Cool. That's pretty much it. Right. So the two big things are, once again, we're hopefully now we're a little bit more familiar with how to pass functions into functions, but now we're actually going to return functions from functions. Right. So that's doable. And then secondly, it's once we return a function, that function still has access to the same scope in which it was created. And so that lets us kind of access variables that we previously could not access before. Okay, cool. I'm going to stop the recording for 1 second here.